Hi, my name is Harsh, and in this video, I'm going to talk about how you can mount your local directories into your ECS tasks that are running on your local machine with the help of LocalStack. LocalStack's Core Cloud emulator allows you to emulate and run over 100 plus AWS services right on your local machine. One of these services is Elastic Container Service or ECS, and you can use LocalStack to create and run ECS clusters or ECS tasks. Now, one of the most exciting features that I love about ECS is that you can use bind mounts to mount your host file system into your ECS task. Now, this is a pretty common scenario while you're developing or debugging your application, where you have to make quick changes, but you don't want to rebuild your task Docker image every now and then to test out those particular changes. Now, with the help of LocalStack, you can also mount your host file system into your locally running ECS task. And this gives you a blazing fast development and testing experience while you are building ECS applications right on your local machine. In this video, I'm going to demonstrate you a simple CDK for Python application that deploys an ECS task, which simply is a Flask application running inside a Docker container. And I'm going to show you how you can use the bind mounts feature provided by ECS to mount your host file system into your task, and how you can get started with testing out your application and making repeated changes and seeing those changes appear in real time itself. So without much ado, let's get started. Before we get started with our practical example, let us first explore what Docker bind mounts exactly are. Bind mounts or host volume allows files or directories to mount directly to the Docker container from their absolute path location on the host machine. This practically means that you can mount your code from the host file system into the ECS container. This practically enables a quick debugging loop where you can test changes without having to build and redeploy the task's Docker image for each particular time. In this practical example, I have got a Flask application for which my code lives in this main.py file. The code is pretty self-explanatory. We have got an index route, then we have got a get route, and we have got a post route. I have kept it simple so that it can serve a pretty good demonstration for us for checking out how mounting local directories for ECS task basically works within LocalStack. To deploy this particular application, I have a Docker file present right over here that packages and sets up the whole application running inside the Docker container. If I get to quickly explain this, you can see that in this particular Docker file, I am using the Python 3.9 Slim as the base image. And this file basically sets our working directory to app and installs the dependencies required for running this particular application right over on these steps. Over here, we copy the main.py file into the app working directory, and we basically expose 8080 as the port and run this particular application right inside our Docker container. If everything is working, the LocalStack's ECS emulation will basically expose a port that would allow us to access our running application from inside an ECS task Docker container. If I quickly go back to my CDK stack that I have present right over here, you might be able to notice that I am using the CDK for Python as my base construct over here. I am setting up the necessary CDK modules and the classes for defining and provisioning my infrastructure. I'm also setting up the VPC required for setting up this whole application. And I have got an ECS cluster over here, which is literally named as ECS cluster, that gets associated with the previously created VPCs over here. You can also notice that I have set up ECS Fargate task definition in this particular step that allows me to specify the Docker image that I would like to use. along with any of the volume that needs to be mounted. If you go back to the first thing that I said before running through this particular application, you might be able to correlate that I'm mounting my service directory over here in this particular case because my Flask application is living inside this particular service directory. Going ahead, you can see that I'm building the Docker image required for deploying this ECS application from this service directories context. And in the rest of the steps, I have added a mount point for the container. And this basically mounts my service directory inside the app working directory of the running Docker container. Lastly, I have also set up an application load balanced Fargate service that basically provisions an application load balancer that allows my local infrastructure to distribute the traffic to the Fargate task that's running inside the ECS cluster. So this is the long and short of what I am setting up right over here. Now to deploy this application, I will be using CDK local, which is a wrapper script that's built on top of the CDK library. With the help of CDK local, I can deploy my CDK stacks to my local machine itself if I have LocalStack installed and running on my local machine. So in this case, you might be able to notice that LocalStack is already running. So I can go back to the other terminal and I can run the first command, which is to bootstrap my whole CDK stack before I actually deploy all of the resources that I have defined over here. This might take a couple of seconds here and there. With the help of LocalStack's ECS emulation, you get a blazing fast development and testing loop that's not possible anywhere else. Now that our stack is bootstrapped, let us go ahead and let us actually deploy our CDK stack. And the interesting part that you will notice is that it's pretty fast. And on top of it, you can go back to the LocalStack logs and you can get to see the whole log experience over here that pretty much communicates how your infrastructure is being deployed and what sort of APIs are basically being invoked. So in this case, you're already seeing a bunch of CloudFormation APIs because this whole CDK stack is synthesized as a CloudFormation template. And if I go back, you might be able to notice that LocalStack is already starting this particular ECS task in Docker. And if you go back, you might be able to notice that this whole stack has been deployed in possibly less than 30 seconds itself. So that's a pretty good speed. But let's not talk about that first. Let's talk about how this whole ECS code mounting is functioning in the background. Now, if I go to my Docker desktop, you might be able to notice that I have got two Docker containers running over here that are basically emulating the ECS tasks. And you might also be able to see that they have been exposed on these particular ports. So if I go back to my VS Code over here, I can go to my LocalStack logs and I can possibly copy one of these ports, which is 47783. And I can just maybe open another terminal over here. And I can hit this particular endpoint using curl. And you might be able to see that I have got the hello ECS present right over here. So you can already see that you can run your ECS applications on your local machine. And not just that, LocalStack also enables a pretty fast development and testing loop for you. But let us now talk about the elephant in the room. Let us talk about the ECS code mounting. So if I actually go back to my main.py file, and let us say that I change this to hello LocalStack, for instance. And if I run this particular request once again, you might be able to see that I have got the hello LocalStack right over here. I can also change this to hello ECS hot reloading. And if I run this the sample request once again, you will see that I have got the hello ECS hot reloading. This is not just limited to this particular example. If I just change this to something like random get request, and let us say that I hit the get endpoint, you can see that the random get request is basically being returned. Now, just to show the quick example over here, if I just open any one of these ECS tasks over here, basically these are being run as a Docker container that emulates the whole setup. You can see that every time I was making a change in my main.py file, the ECS task was able to detect it and it restarted my Flask development server. That gave me a pretty good idea about how my changes is basically being reflected as part of the real infrastructure that's deployed on my machine. And obviously, this is going to act the same when you deploy it on the real cloud. If I go to the inspect and let's maybe instead go to the files, you might be able to see that all of my code is mounted into this app working directory. And this has got the main.py file. And this is where you might be able to notice that all of the changes that I did is basically automatically mounted into this particular Docker container, which is mimicking how a ECS task will run on the real AWS cloud. So that's the whole story behind ECS code mounting with LocalStack. And this is how you can practically achieve a blazing fast development and testing workflow. If you want to explore further, we already have the sample GitHub repository that's publicly available. And you will find the link for that in the description down below. So that was a long and short about how you can use the ECS bind mount feature alongside the local stack for a local first ECS development and testing experience. If you would like to walk through the sample application yourself, you can find the link to the GitHub repository right in the description below. You will also find some documentation for getting started with ECS on AWS or on LocalStack if you're new to this particular service. In the future videos, I'm planning to explore more such exotic use cases where you can use LocalStack for a seamless developer experience alongside various other AWS services like step functions or even Bridge, for example. In the meantime, I hope you have a great rest of the day and I hope to see you in the next video. Peace.